In this demonstration, we'll build a translation from data held in a source database into an XML schema. We'll use the CDX Mapper to do this, which is a development environment specifically designed to aid in this process. The CDX Mapper shown here has three main panes in the top portion of the window. The left-hand pane, which is the Queries node at the top, is the source of the data for the translation. In this case, the source is a database, and we'll be constructing a query to provide the data to be translated. The right-hand pane, with the root node at the top, contains the target for the data being translated. In this case, we'll load an XML schema that defines the structure of the data we are exchanging. The source and target data will have different structures and different storage mechanisms. We'll use the center pane, or mapping window, to create translation from the source to the target. When we're all done, we'll have an executable set of rules that defines what needs to be done to the source data in order to create XML that conforms to our agreed-upon exchange. The first thing I'll do will be to create a query in the source pane. When I right-click on the Queries node, I see all of the databases that I have configured CDX to recognize. Each of these can represent a different database, and indeed, each may be stored in a different database product, such as MySQL, Microsoft SQL Server, Oracle, and so on. We'll be extracting person information from the source database, so I've named the query Person and have selected the Sheriff data source to provide the data. In the Sheriff database, I have 4 different tables. I'll be querying the Person table, which will give me some basic information about people. Notice that address information is held in a separate table named Address. We'll come back to this table later in order to extract information from that table as well. Once I've selected the table from which I wish to extract data, next I need to indicate which columns of data I need access to. I don't need to pull the whole table in, but rather I can select just the columns that are of interest to my exchange. When I'm done, I have a representation of the information that I need that can be used to generate SQL to send to the database. If you wish, you can modify this SQL directly. You can execute the query in order to see what the data will look like that you'll be getting from the database. CDX Mapper was built to be a development environment, so you'll see that you can always examine the source data as well as incrementally run the exchange mapping as you modify it in order to visualize what the data you're creating looks like. The query row set now is shown in the source panel. Next, I need to load the XML schema that is the target for the data mapping. It doesn't matter if this is a standalone XML schema or is defined as part of a NIEM-conformed IEPD. NIEM IEPDs tend to be very complex, but the CDX Mapper is well equipped to deal with that complexity. To load the schema, I simply right-click on the root node in the target pane, and I see a list of all the schemas that I have configured in the system. Since XML schemas can define a whole collection of elements and types, when I load the schema, I need to identify the root element for the exchange payload. After I've done this, I see a tree representation of the schema in the target pane of the CDX Mapper. Note that I can get some information regarding the source and target data types. If I click on the driver's license state field in the source database, I can see that this is a character field holding 2 characters of information. In other words, this is the state code. Likewise, if I click on elements in the XML schema target pane, I can see the schema type that is expected for this element. I'm now ready to begin my mapping work. Some data will need to be directly copied from the source to the target. No translation is required. For example, my source data already has a first and last name for each person, so I can use these data values as is. To do this, I simply click on the source field, drag it across the mapping window, and drop it into the target element in the XML. The line connecting the source column and the target element indicate that this translation is a direct copy. At any point, I can pause my work and look at the data that would be created by the current mapping. I specify how many rows of the source database I'd like to extract, and then these rows are run through the mapping. The window now displays the target XML. Notice the name fields have been copied to the output without modification. Not all of the data that I need for the exchange may exist explicitly in the source database. For example, perhaps I need to provide the ORI of the agency who is providing these data. The owner element in the target schema is a place for this, but the database doesn't contain the ORI, but rather the database is owned by a particular agency. In order to handle anything other than direct field mapping, I'll use mapping objects. In the left-hand panel, I've turned on the Mapping Objects toolbar. There's a collection of objects that allow me to do all sorts of manipulation to the data, from creating constants, trimming white space, concatenating multiple fields into one, or even aggregating multiple roles into a single text string. The functions here have been developed over years of doing real-life deployments and represent the tools that you'll need to be successful. I'm going to grab a constant object and place it into my mapping pane. If I double-click on this object, I get an editor that allows me to modify the properties of this mapping object. For the constant mapping object, the name is used to create its value, so I'll enter the ORI of the owner agency and map that to the appropriate place in the target schema. In addition, I may need to capture the actual date that this exchange took place. I can slide my Mapping Palette tab to show me predefined objects, such as one that generates the current time. I'll drag that into my mapping surface and wire it up to get the current time. If I rerun my mapping now, you can see the ORI and current time in the output XML. Next, I'll return to the person's name. Notice that I'm asked for a full name, not just the first and last name. To create the full name, I need to take the last name, add a comma, a space, and the first name. I can use the concat object to do that, wiring up the various components from the source data and setting the joining string in the property panel. Notice that each mapping object has a script window that allows me to add project-specific logic. If I run into a situation where I need to do something unusual, I can always add my own logic to implement the behavior needed. Finally, I need to get the address for the person that I'm translating. However, address information is stored in a separate table in the database. To do this, I could have created a join in my SQL and tried to create one query that gives me all of the components I need. But the CDX Mapper allows me to take a more modular approach to this problem. I'll create a subquery object, which queries a table while taking an input parameter to use in the where clause. The table comes from the same database, but this time I'll pick the address table. For the subquery, I need to identify the input to the query. This is the set of values that will be used to extract specific rows from the table. In database terms, I'm traversing a parent-child relationship between these tables. My input is the person ID, which is the primary key in the person table, and a foreign key in the address table. I identify this as the input column, and then proceed to select the columns from the table whose data I need to transform. Think of this object as saying, given a specific person ID, retrieve the address information from the address table for that person. Now I can connect the person ID from the initial query in the person table and pass that as the output to the address table and map the individual rows of the address subquery to the output elements in the XML schema. If I now run this mapping, you'll see that I am now aggregating information from multiple tables into the XML Exchange payload.